Section 1.4, Requirements for Human Life. So we're going to take a look at why oxygen and water are critical for survival, but we're really going to focus on body temperature. So if you remember from biology, oxygen is a requirement for doing aerobic cellular respiration. Remember, aerobic means you need oxygen. Anaerobic means you don't need oxygen. So here's an easy way to remember. Even though I look like I'm totally fit, I'm really not in great physical shape. So if I was to take an aerobics class, I would probably need an oxygen mask strapped to my face so I don't pass out, right? So aerobic requires oxygen, anaerobic does not. Water is critical for survival because water is the medium in which all our chemical reactions in the body occur. If water is not present, those chemical reactions cannot occur and we will not survive. But as I said, let's take a look at temperature. So as far as temperature goes, we're going to first look at heat loss. So there are a couple methods, 4 methods of heat loss for the human body. There's evaporation, convection, conduction, and radiation. So we'll take a look at evaporation first. So you might remember from some of your chemistry or physical science classes. If you don't remember, that's okay. That's why we're doing this. This is called a phase change diagram. So on the bottom we have time. That would be the independent variable on the x-axis. On the left-hand side we've got temperature, and that would be the dependent variable along the y-axis. An S with a parenthesis around it like this means solid. An L parentheses lowercase means liquid. G with parentheses means gas. So this is a phase change diagram. So basically we start off with solid ice down here at time 0. The temperature is very low, right? And we're going to apply some heat. And we're going to heat up that ice and it's going to start melting. And then here we're going to have basically ice water, and we're going to keep on heating it. And now we have all water, and we're going to keep on heating it, heating it, heating it. And now we're going to have a mixture of water and water vapor because the water is now boiling and evaporating. So here's the mixture. And here we have just water vapor in gaseous form. Okay? So in order to go from liquid water to gaseous vapor, we call that evaporation. And in order for it to evaporate, you need to add heat. Okay? Boiling water on the stove. It's not going to boil unless you add heat. Now in our bodies, on the surface of our bodies, our sweat glands produce sweat. In order for that sweat to go from liquid to vapor, we need to add heat. What if we stood underneath a tree in the shade? We're taking the sun out of the equation here, okay? So what if you're working out, you're cutting the grass, you're doing something like that, and you're sweating. You go stand underneath a tree in the shade. That sweat will still evaporate. And it still evaporates because it's using heat to go from liquid to a gas. That heat is coming from you, your human body. And if we take the heat from your body, it's going to lower your body temperature. So, in summary, in order for you to lose heat via evaporation when you're overheating, that sweat needs to evaporate. If it doesn't evaporate, if it simply drips off your face, it is not helping you. You're actually losing fluids. You're getting dehydrated. That sweat needs to evaporate. So here's a situation on the left-hand side. We see a sweat gland right here, and here's a duct, and the sweat is now on the surface of your skin, and it's evaporating. On the right-hand side, we have a diagram here that shows a humid environment and a less humid environment. So think about it. If you go out west to someplace like California, Arizona, I've never been out west, but from my understanding is that it's a very hot environment, but it's very dry. So when you're outside sweating, that sweat quickly evaporates, and in doing so takes the heat from your body and drops your body temperature back down to normal. Whereas, let's say Louisiana or someplace in the summer, it's really hot, really humid, like or a tropical environment. Very hot, very humid. The problem is the air is so saturated with vapor, with water vapor, that the sweat doesn't evaporate off you. It drips down you. So that means that when you're in a humid environment, when the sweat's dripping off you, you're not going to lose heat as effectively as when you're in a dry environment. Here's another way we can lose heat. This is convection. Convection is when there's a fluid that passes past your body and draws heat away from it. Because heat always flows from high heat to low heat. You never go from low heat to high heat thermodynamically. So convection involves both water and or wind. This is why it's when you're standing outside in the cold and it's a windy day or even a sunny day, the wind will help pull some of the heat off of you and cool you down. It also happens in water. So your body temperature is 98.6 degrees Fahrenheit. If you were to hop in a pool and just stand there, if the pool water is at 80 degrees Fahrenheit, you're actually still going to lose heat, even if you're not swimming or moving or anything. Okay? So convection can be any fluid, but primarily air and water. A third way we can lose heat is through conduction. An example of this would be putting an ice pack on your head or on a sprained ankle, sitting on cold metal bleachers watching a football game. The heat is going to get transferred from you to the bleachers. Conduction, you have to have direct contact with another object in order to conduct heat. And lastly, radiation. This is the reason that we have lids on our coffee cups, on our travel mugs, because we will lose heat. You can't see it unless you have an infrared camera. Okay, this diagram is a summary of all of those heat loss methods.